Okay, hello guys. So I got a question. I thought it was a good question, and I wanted to make a video to answer it. The question is, are we going to need to remember chemical reactions for the exam? And the answer is, in short, yes. You do need to remember chemical reactions. Specifically, you'll need to remember the reactions associated with, well, I guess there's a number of different ones, but the one that we're talking about, what I'm going to talk about right now, is when you're answering the question for what is pH at different points along the titration curve. So when you're answering this question, okay, my stylus really sucks. There are a number of different chemical reactions at play. So if you're trying to figure out what kinds of chemical reactions you're going to have to memorize for the test, there are 2 or 3 specific ones that I'm thinking about that you're going to need to know how to figure out. In the context of this question, what is pH at different points on the titration curve? A lot of times the first part of that question is initially before you've added any titrant. So maybe you're titrating a weak base with a strong acid or a weak acid with a strong base. The question is saying what's the pH before you've added anything to the reaction, before you've mixed the titrant in. So that's an initial equilibrium reaction for whatever the weak thing is, whether it's the weak acid or the weak base. And so let's just take the case where you have a weak acid. We've looked at this example a lot in class with acetic acid. So if you have the weak acid initially, right? And you're going to titrate it, but you haven't started titrating it yet. So you just have the weak acid in solution. You're looking at an equilibrium reaction for the acetic acid. Oh boy. In water. Right? So this is the reaction that we're looking at. H3O plus, and then you'd have the acetate anion or the conjugate base, right? Okay, so yes, you do need to know how to write that reaction. I'm probably not going to give it to you on the exam. The second reaction that you might have in that on the exam, or actually it's still part of the same question, right, is at midpoint, right? So you're titrating along and you've added a certain amount of base to this weak acid. And at the midpoint you have half weak acid and half base. And you can think of this reaction as the acetic acid plus whatever strong base you're adding. Let's imagine we're adding sodium hydroxide, right? And this reaction is not an equilibrium reaction. You're forcing the formation of water and the salts, in this case sodium acetate, so NaCH3COO minus. Now, you don't really need to know this chemical reaction for part 2. This is where you are at the midpoint of a titration curve, and here your pH is equal to pKa, and it's the pH that we're interested in. So if you remember that at your midpoint your pH is equal to pKa, then you don't really need to write out the chemical reaction. If, however, you're trying to show your work to get partial credit and you do write out that reaction, you might get some points for writing it. Okay, so then what would be the next part in this titration problem? We would have at the equivalence point, right? So that's the third place where we've been asked, or you've been asked to do a pH calculation. And at the equivalence point is the really interesting one. The equivalence point is when all of the acetic acid has been titrated. So all of your acetic acid has been forced to become the acetate anion. And at equivalence point, we look at the reaction of the conjugate ion, in this case, the acetate anion, in reaction with water. And that is an equilibrium reaction. And you do really want to be able to write that reaction to do an ice table. So this is the reaction at equivalence point for the titration of a weak acid with a strong base, right? And at equivalence point of a weak acid with a strong base, we have the formation of hydroxide ion, which causes the base, which causes solution to be basic, to have a high pH, greater than 7. Okay, and then the last scenario here when we're talking about the titration problem is after equivalence. So that's our fourth point, and this is when we're just adding, in this case, we're titrating the weak acid with the strong base, so we're going to be adding strong base to water, right? We consider everything up to this point sort of blank slate. We ignore it all, and now we just have a solution of water, and we're adding more strong whatever. And in the example we're looking at, we're talking about strong base, okay? And so in this case, you're going to be adding sodium hydroxide to water, and this reaction is just going to make a bunch of hydroxide ion floating around in water, and so it's going to make the solution basic also. Where's the rest of my reaction here? And then obviously I'm going to have some sodium ions floating around as well. And that's just lovely. I apologize for the quality of the stylus. It basically sucks, but I think you get the point. So those are the kind of the chemical reactions that you would need to be able to write for your exam tomorrow. Oh, also on this last one again, for this calculation, when you're calculating pH, you don't really need to be able to write the reaction. The important ones are the first one, this one, oops, this one, and the third one, this one. Though that's where it's really helpful to be able to write the chemical reaction. So, and where if you don't get it right, but you do write the chemical reaction, you probably get some partial credit. All right, that concludes this video. Let me know if you guys have further questions.